our first problem, I actually want us to go back to the problem I started with because I couldn't do that before. Hopefully now I have a new method, I can do it. So let's try, again, just to remind you what we were doing. Find the volume of the solid obtained by rotating about the y-axis the region bounded by y equals 2x squared minus x cubed and y equals 0. Same exact setup as we started with. I'm going to draw my picture, which we already did, so I don't have to find the intersection points because we've already done that. I said it looked like goes through the origin to 0, and our region looked like that. And I'm rotating about here. So my strips now, remember, we're taking them not perpendicular, but parallel. So up and down. And rotating around. So this is the same setup that we had in that picture of before I gave you the formula. My radius here is x. We're integrating in terms of x again. So my radius here is x, and my height is y. But I'm going to integrate in terms of x, so this is going to be 2x squared minus x cubed. And now we set up our integral. The volume.
So the radius is always x, correct?
If we're rotating about the y-axis, yes. We are going to rotate about the x-axis later, and then that'll change. It'll also change if you're rotating about a non-axis line. It'll be different, yeah. Okay, the volume is the integral 2 pi r, which is x, the height 2x squared minus x cubed. And then what are my bounds on my integral going to be? 0 and 2. My integral is in terms of x, so I need to look at my range of my x values. They go from 0 to 2. So if it was me, I would factor out this 2 pi in the front. Factor that out first before you integrate. This becomes 2x cubed minus x to the 4th, and then integrate after that. You should get 2 pi, what? What happened to the x? I distributed the x, so it became an x cubed and x to the 4th. What's the integral of 2x cubed gonna be? Yep, so x to the 4th over 2 if I simplify my fraction. And then x to the 5th over 5, 0 to 2. Plug in your top number, your bottom number gives you 0, and you'll get 16 pi over 5 when you're done, I think. So this is particularly nice if you're rotating about the y-axis, because now before my integration variable had to be y, but now my integration variable gets to be x.